How can you prevent noise in analog signal amplification? Imagine trying to listen to a whisper in a noisy room. That's what noise does to an analog signal during amplification. It makes small signals hard to detect and can distort your data. To keep your signals clear, you need to understand where noise comes from and how to fight it. Noise in analog circuits can come from many sources. Thermal noise happens because of the heat in electronic components. Shot noise results from the random flow of electrons. Flicker noise, also called 1/f noise, affects low-frequency signals. External interference from power lines or radio signals can also sneak in. The key is to improve the signal-to-noise ratio, which compares the strength of your desired signal to the background noise. The higher the ratio, the cleaner your signal. One of the first steps is designing your circuit carefully. Keep analog and digital parts separate on the circuit board. Use a solid ground plane and avoid long, parallel traces that can act like antennas. Place bypass capacitors close to the amplifier's power pins to filter out high-frequency noise. Using shielded cables, like coaxial cables, helps protect your signals from environmental noise. Twisted pair wiring can also reduce magnetic and electric interference. Differential signaling is another powerful method. It uses two input lines to measure the voltage difference, canceling out common noise. High common mode rejection ratio amplifiers are best for this. Managing bandwidth is also important. Limit the amplifier's bandwidth to only what you need. Wider bandwidth allows more noise to pass through. Use filters to block out-of-band noise. For example, if your signal is below 1000 Hz, set your low-pass filter just above that frequency. Analog filters, whether passive or active, can remove specific noise frequencies. Notch filters are great for eliminating power line interference at 50 or 60 Hz. After the analog to digital conversion, digital filters can further clean up the signal, but filtering before conversion is often more effective. Choosing low-noise amplifiers is essential. Instrumentation amplifiers or chopper-stabilized amplifiers are good options for very small signals. Adjust the gain carefully. Too much gain can cause clipping, while too little leaves your signal vulnerable. For environments with changing noise conditions, adaptive filtering techniques like Kalman filters can help. These algorithms adjust in real time to improve clarity. Modulating your signal to a higher frequency before amplification can also move it away from low-frequency noise sources. After amplification, you demodulate it back to its original frequency. Noise cancellation circuits generate an inverted noise signal to cancel out unwanted interference. This method is common in audio but can be adapted for other analog systems. In control systems, keeping signals clean is vital for stable operation. For example, in temperature control, noise in sensor signals can cause erratic responses. Using differential amplifiers, shielding, and filters helps ensure the system only responds to real changes. In labs or factories, where signals are tiny, every step counts. Use high-quality connectors, keep cables short, and ensure proper grounding. For ultra-low noise needs like electrophysiology or precision measurement, special low-noise amplifiers or cooling techniques can further reduce thermal noise. By addressing each noise source with the right techniques, you can greatly improve your analog signal quality. Proper layout, shielding, filtering, and selecting the right components all work together to keep your signals clear and reliable.